Good morning, good afternoon, good evening, depending on the time and where you're watching us from. Today, we want to finalize on our topic and subtopic on chemical families. So there are only three things remaining, but from the list I sent to you, I only wrote two of them. So we have group 7 and group 8, basically halogens and noble gases, but we also have across the period. We are also supposed to discuss across the period. So those are the three concepts we are supposed to discuss today. How many are in? How many are watching me? How many can hear me? What we were discussing? So I hope you've been following these lessons since the beginning of the topic, because actually at some point we will require to refer to what we have been discussing all through. So I'm going to start with halogens. Halogens. Now halogens, in a Greek word, halogens means salt. Halo means salt. Gen means making of it, just like generating. Halogens now means salt formation or making of a salt. Now, from what we know, when we talk about halogens, these include fluorine, includes chlorine, includes bromine, and iodine. These are the halogens. When you take a metal, when you let a metal react with any of these, it will give you a salt. There is something I've said, that halogens is made up of two words. Halo, which means salt. Gen, which means to make. So basically, halogens is the salt formation. So halogens, these particular elements, which are known as halogens, are basically used to make salts. Now, the way they are, or the way they appear here, halogen has there are four of them. So fluorine is atomic number 9, chlorine is atomic number 17, bromine is atomic number 35. I know you guys are used to the first 20, then ingine is 53. So this or that is what you are supposed to know. But basically, because of the first 20 elements, this is what we are supposed to know. The other thing that you need to know about these halogens is that they exist as molecules. They exist as molecules. Why? Because you cannot write as chlorine as Cl. No, it exists in more than one atom. So we have it as Cl2, F2, I2, Br2. They exist as molecules. That's what you need to know. They form ions by by gaining electrons. Like fluorine is 2:7, chlorine is 2:8:7. So they gain one to make complete. So it becomes 2:8. Okay, 2:8. Ingene 2:8 and 8. So these are the ions. So they form what we call anions. Anions, you know what anions means? Anions means negatively charged ion. The opposite of anions is what we call cation, positively charged ions. Are you following? Yes. So now, up to that point, there are two things I would like us to check on. I would like to look at what we call the gradation of the size down the group. As you move down the group in halogens, what happens? So I will be asking it in terms of questions. Then we discuss it. I've prepared for you in terms of questions. So I will be displaying the question in the chat section. I will be displaying the questions in the chat sections. Then we answer that question the way we want immediately. Kidogo too. The first question is asking there, explain the trends in the atomic and ionic radius of halogens down the group. Are you seeing that question? Yeah. Margaret and Jerry, thank you. And yes, I am in. Let's discuss this. Margaret, look at that question. Explain the trends in the atomic and ionic radius of halogens down the group. Good. Tuanze na hiyo. Let's start with that one. Si lazima utype hapo, lakini if you can, you do it. Hey, what do you think, or how do you think is the trend of the atomic and ionic radius of halogens down the group? We are using the same concept we used in group 1, in group 2, and it can be used in all the other groups. So what is there easy? If this is the trend, we have fluorine, we have chlorine, we have iodine, okay, bromine first, then iodine here. Now, ansemaje? No, mwambie nikuleza kidogo. So, kama nasangoja for 30 minutes iko sawa? So now, so the trend in terms of size is how does it work? Now, as you move down the group, there is increase in number of occupied energy levels. For example, this one has 2 because it is 2, 7. This one has 3. As you move, I'm not telling you the energy levels of this, but they are more than for this because beyond 20, it does not follow the issue of 2, 8, 8. No, it becomes 2, 18, 18, ikisonga mbele huko. So as you move down the group, there is increase in atomic size. There is increase in atomic size. At the same time, as you move down the group, there is increase in ionic radius and ionic size because of the same reason. Yes. Now, that is the first question. We can, unless kama kuna mtu akona swali, you can ask. I want to move to something else. Yes. Hii nilikuwa nime once again ask it. When I was mentioning something, nikasema kuna swali hapa nataka niulizie kidogo. The question reads, how do the atomic radius of the halogens compare with their ionic radius? Well, how do they compare with the ionic radius? Hii nayo nataka mshike vizuri. It's my third time explaining it. Let me explain it once again because this is the right place to explain that. How do the atomic radius of halogens compare with their ionic radius? Always, the ionic radius is larger than the atomic radius of the same element, the same atom. That is, if you pick chlorine atom and chlorine ion, this one is larger than this. Is greater than, you use that sign, greater than this. Now, after saying that, we need to explain. How is this greater than this? You know, yesterday, or was it yesterday or the other day, I always love using sodium and sodium ion. But that's why E equal to 2, 8, 1. E equal to 2, 8. So it is easier to explain this because E equal to 3 energy levels, E equal to 2. So this one is greater than this. Gotcha. This means less than. No, this one is greater than this because it has 3 energy levels. This is 2 energy levels. Now in this, chlorine has 2, 8, 7. Chlorine ion on that side has 2 is to 8 is to 8. So you cannot explain using the concept of sodium. Why? These ones, they have the same energy levels. 3 energy levels, 3 energy levels. Are you together? The reasoning is this, for those who are writing. Okay, first of all, the atomic radius of the halogen atom is less than its ionic radius, meaning the ionic radius is larger than the atomic radius. Who can give us the reason? The one I've given here is long, and but no, I will put it. I will explain, then I put it. I don't know kama itatosha. Let the technician give you the reasoning. Okay, we see. Is potosha, I will explain. The comment section saa zingine no, imekata, it's too large. So let me explain. Now, this one, it has 17 electrons. This one has 18 electrons. Remember, from the law of charges, electrons versus electrons, they repel. Now, kumbuka, these electrons are distributed in the various energy levels. 2 iko kwa the first energy level ingine iko na 8, then the other energy level iko na 7. So these ones are repelling with this. But now, if we increase the electrons in the outermost energy level ikue 8, hapa ni iko 7, but kwa ingine the outermost energy level hapa iko na 2, but kumbuka kuna nucleus, then 8, then 8. Now, there is an increased repulsion between the gained electrons and the existing electrons. Therefore, the outermost energy level moves far away from the nucleus. That is why the ionic radius of chlorine is larger than the atomic radius. Anybody with a question? Yeah, there's something I've given there. The reduction of the nuclear attraction is due to the repulsive effect between the existing electrons and the incoming electrons. Good. Another question is still in the halogens. No, quite that before that. Okay, the question I want to ask is about physical properties. Daga tuanze physical properties very fast kidogo. I want us to give the color of fluorine, chlorine, bromine, and iodine. Can you type for me there? What is the color of fluorine? Iodine. What's the color of the 4 halogens I've given? Type it very fast. Some of you wanasema so nikitype kitu ikuwe wrong, watu wengi watakuwa wanaona hakuna shida. You are already ahead of them. You're already ahead of them because you are in a lesson, they are not in a lesson. Na wataonea wapi kwanza na wako lesson? Nataka tupeane the colors of these gases. I'm waiting for you. Timothy anasema iodine is brown. I'm waiting until all the 4 halogens are mentioned. Ndio nianze kupeana. Iodine imepeana, mwingine apeana nyingine. Yesterday I mentioned the 2 colors. I mean the color of chlorine and fluorine, by the way. Jana nilipeana. Kama ulikuwa my lesson yesterday, I mentioned it. Jerry amesema fluorine is pale yellow. Daga mwingine, I still need 2 more. So I've been mentioned. So someone to mention about chlorine and bromine so that we can proceed. Ndio niwape haraka uone kama umepata ama hujapata. Margaret again anasema bromine is brown. Thank you. Ya mwisho kabisa, chlorine. Lastly, we are waiting for chlorine so that I can give you someone is saying Nasir is saying fluorine is pale yellow. Okay, I can see very many answers. That's great. Now listen very fast. Are you ready? Ujue kama umepata ama hujapata. Fluorine is pale yellow. Yes. Chlorine is, now I'm giving you this, then I will explain green, yellow. Green, yellow. But in an exam, when you ask, don't say green, yellow. There is no color called green, yellow. In exam, you pick one, and that is yellow. Just pick yellow. Like for fluorine also, don't say pale yellow, just say yellow. Bromine is a liquid, it's a brown liquid. Bromine is a brown. Bromine, B for B. Bromine is a brown liquid. Iodine, dark solid. I'm a shiny dark solid. Shiny dark solid. Shiny dark solid. Yes. Now there's something I want to explain kidogo before we proceed. Kuna kitu kinaitwa bromine liquid. Then we have bromine water. Bromine liquid is brown. Bromine water is yellow. Don't confuse the two. Bromine water is bromine which water have been added to it. It changes from brown to yellow. Yes, so you don't confuse the two. Good. Thank you for all those replies, Margaret and Timothy. Sawa, sawa. As you move down the group, what is the trend of melting point and boiling point down the group? What is the trend of melting point and boiling point down the group? How does it change? Explain the trends in the melting and boiling points of halogens down the group. Kuelewa hii kitu haraka inakuwa rahisi. Fluorine is a gas. Chlorine is a gas. Bromine is a liquid. We are moving from a gas to a liquid to a solid. Down the group. So the melting and boiling points also increases down the group. Are you together? Yes. So now another question. One more question. Now this question that I want to ask specifically deals with iodine. What happens or observed when iodine is heated? What happens when iodine is heated? What happens when iodine is heated? Explain what is observed when iodine is heated. Hiyo ndawangojea mniambie. Explain what is observed when iodine is heated. Kumbuka iodine tulisoma tukiwa form 1. Mnakumbuka when we were learning about mixtures, separation of mixtures, what did we say about iodine? Tulisema nini kuhusu iodine? Njeri anasema it sublimes. Well, it sublimes. But what do you observe? Sublimation is a general statement, Jerry. Now, what will I see? Jerry, let me give you now the full answer. Check on my chart. Inasema hivi. Jerry, sasa umeongea vizuri. Iodine sublimes when heated to form a purple fiber. This is because the particles are held by weak forces which require little energy to break. That's what I wanted you to tell me. What your eyes can see. Are you together now, Jerry? And that is good. Aya. I will not talk so much about chemical properties because we learned actually about how to write chemical equations vizuri. If I repeat the same thing, it's again like we are repeating ourselves. So thank you. that write the following chemical equations. Any equation, any reaction that chlorine can participate in or at makes that one a chemical property. I don't think there's something else. Now, write for me equations between chlorine and any other metal. Between chlorine and any other metal. You know very many metals, but you can just come on the chlorine, pick one metal. Fluorine, pick another different metal. Likewise to bromine and iodine. So that at least tushike venye inafaa ikue. Aya. I hope we were together. Number 2, andega equations musuri. Just write very proper equations. Now, as you are writing those equations, there is this question here. What is the order of reactivity of halogens? What is the order? I'm placing that question up on chat. What is the order of the reactivity of halogens? That is, how do they react? Which one reacts faster than the other one? Hiyo mtaniambia. Down the group, does it increase or decrease? Hiyo ndawangojea mniambie. Does it increase or decrease? What is the order of reactivity of halogens? And you're told to explain. Nawangojea mnipe kwanza. And we said when you join class, you be disciplined, you stay up to the end. No quitting hapa katikati. Hakuna kuquit hapa katikati. Sawa. 1 minute remaining for those who are still typing. Then, from there we will look at the uses of halogens. Get ready, as I'm giving you uses of halogens. What is the order of reaction of halogens? As the atomic size increases in halogens, the forces of attraction also increases. That is why we start from a gas to a solid. Are you together? So as you are moving from fluorine, ukienda chlorine, uende iodine, and then hapo jini kidogo ukutane na bromine. Okay, it's bromine then iodine. The forces of attraction increases as you move down the group. Now, let me say this. As you move down the group also, there is a decrease in the rate of reaction. Meaning, the one that is above, that is fluorine, is more reactive than all the others down the group. Yes, so that's what you need to know. We start from fluorine, the most reactive, followed by chlorine, followed by bromine, and lastly, iodine. I hope we were to get up to that point. Yeah. We want to get to the uses. Makre umeandika chlorine plus ion, it gives ion 3 chloride. That question is very okay. Yes, kabisa kabisa. That equation is very nice. Yes. Now let's get to uses of halogens. We are studying uses of halogens, and I will be reading you as you use. So we are very many in class. Let's write them there very fast. Let's write them there very fast. And don't tell me halogens are used in. Tell me the specific halogen. Kama ni chlorine, niambie chlorine inatumiwa kufanya nini. Kama ni fluorine, tell me what fluorine is used for. Yes, so I'm ready to read your answers, and I'm also ready to provide my answers. So faster kidogo, just take that phone ama kama ni laptop, type haraka utuambie what are the uses. And by the way, in chemistry exam, you would never miss a question asking you to state about the use of. That exam will never be complete without it. You must state it. Sawa. Boys and girls, you have to. Starting from Form 1, stating the use of oxygen, hydrogen. In Form 2, you're stating for chlorine, for carbon dioxide, for carbon dioxide, and very many others. Yes. Let me see whether you guys are giving me answers or not. Wesley, you're asking why is fluorine the most reactive halogen? Can you say because? Can you say because it has high electron affinity than the others? Because it has high electron affinity than the others. Mashika Wesley? Yes. Because it has high electron affinity than the others. Good. Sasa watu wengine wataki kuleta answers. Haya, tuanze. Daka twende very fast. I will be portraying within 30 seconds nimeenda ingine. So the first use ndio hiyo nimeweka hapo. Fluorine is a raw material in the preparation of synthetic fiber known as polytetrafluoroethene. That is the first use. As you are reading that one, I want to give it the second use. Remember, there are 9 uses. Another use, I'm pinning it on the screen. The second use. Some compounds of fluorine are added to water and some toothpaste in small quantities to reduce tooth decay. So we know about tooth decay. That's why chukua nini ya Colgate ama any dawa ya meno uangalie. Fluorine is a part of the compound that is placed there. Fluorine still is used in the manufacture of hydrogen fluoride that is used to engraving words. Tuko use number 3. Sawa? Fluorine is used to manufacture of hydrogen fluoride that is used to engrave words of pictures on glass. You've seen this in buildings where decoration has been done. Daka nishike 2 uses safari moja. I want to paste 2 uses safari moja to save time. Number 4 and number 5. If you are writing, usiandike ni kama mikono yako yote ni ya left. Andika very fast. So number 4, chlorine is used to make bleaches used in paper pulp and textile industries. And then chlorine is added to water to kill microorganisms in water treatment works. Tuko number 5. So 26, 7, 8, and 9 uses of halogens. Unaona kama niko haraka sana? You will refer to the video later on. Number 6 and 7. Number 6 and 7 ndio nataka kukuweka kwa screen sahi. The use number 6 is chlorine is used in the manufacture of plastic known as polyvinyl chloride, PVC. Ukifika form 3 kuna topic ya chlorine, network chlorine and its compounds. You will study about that one. Chlorine is used in the large-scale manufacture of hydrochloric acid. The same you will study in that particular topic. second last. I know kumeboeka. Lakini sasa utaboekea nani? Bromine is used in the manufacture of silver bromide, which is used to make the light sensitive photographic paper and plates and films. Lastly, ya mwisho, alafu tuende, kuna assignment fulani kitaka kuwapea kidogo about halogens. Make sure umefanya. Pia usipofanya, si niwe ndio utakutana nayo siku ya mtihani usema I wish ningefanya siku ile, sasa ningekuwa na idea on how to go about. A solution of iodine in alcohol is used as a disinfectant. Margaret, what's your question? Why do we not have live audio? You want to, instead of typing, you want to comment live. That one, it will disturb you because it means that you will require to have, it will be hard for you, Jerry. So for now, in YouTube, it allows you to make the comments there. Sawa, Jerry? You just type faster. But next time, I will consider that. But not everybody will manage to do what you want to try. Sawa. Ndaka nipeane kasi ingine. Assignment kidogo tu before niingie noble cases. Assignment hii. Chlorine plus water. React chlorine plus water. Before the end of the lessons, nipatie hiyo equation. Chlorine plus water. Now, niko na swali ingine. Hebu sikia swali. What are the observations made when blue and red litmus papers are dipped in chlorine water? Okay, chlorine water ni ile water containing chlorine, water in which chlorine gas has been bubbled through. Now, you have two litmus papers, the blue and the red one. Umeidip ndani. What are the observations? And explain your observation. Oh, but already nimeclear about. I'm just waiting to see what you will tell me. If you can hear me, please answer me very fast. Why is chlorine referred to as the most reacting non-metals? It's not the most reacting non-metals. Umeachia fluorine wapi? Fluorine is the most reactive. It's only that mostly we don't mention fluorine. Fluorine is the most reactive. Yeah. Watu wakichoranga periodic table, they omit fluorine and they bring in chlorine. So in that periodic table, chlorine will be most reactive. But generally, chlorine can never be reactive than fluorine. Yes. Kisumu County, anasema I know not good enough in the class, but with time you will make me pull up my socks. So don't worry. You will make it. So you will really make it. In fact, we encourage you. We always study chemistry in 4 channels. We alternate 2 of them. We alternate shifting grades and mathematics guru. But the ones which are always on is Ambassador Speaks and Mickey Slate Media. So follow it daily and you will grow your chemistry knowledge. I'm here to help you. Just daily have your bundles. Ingianga Shifting Grades, Ingia Ambassador Speaks, Mickey Slate Media, and the Mathematics Guru. It's called Edwin, the Mathematics Guru. So those 4 channels will help you grow. And if you are in need of any question, talk to the Shifting Grades or talk to myself. I will see what to do with you. Now, I'm asking a very simple question, but that no one wants to answer it. I don't know why. Nauliza swali. Marley, nakuanga huku kila siku. Every day. Sawa sawa Marley. Chlorine gas changes. No. Mind mastery. I'm thinking, by the way, now let me explain this. If I've said I've given you litmus papers, the observation should be on the litmus papers, not chlorine. In fact, there is no chlorine. I'm talking about chlorine water. I hope I'm clear there. So the observation should be on the litmus papers, not the chlorine water. Beverly, let me read your comment. Blue litmus paper stands red and blue litmus paper remains the same because the solution is acidic. Your answer is half baked. Can you bake it ive vizuri, Beverly? Kuna kitu tu kadogo that I will explain. Wacha nione kama well, let me explain this. Let me just talk about this. Let me write this equation. Can you focus now? Look here. Chlorine gas plus water, which is liquid, will give us chloric 1 acid and hydrochloric acid. All of them are aqueous. This one, HOCl, some people will write it as HClO. It is still allowed. Let me see if it is balanced. Hapa kwanza inafaa ikuwe chlorine molecule. Yeah. So this one, it is called chloric 1 acid. Chloric 1 acid, or some people will call it hypochlorous. Hypochlorous acid. Sawa? This one, it's hydrochloric acid. Yo mnaijua. Now, this hypochlorous acid or chloric 1 acid is a bleaching agent. It acts as a agent. Now, HOCl, you know what makes a substance like this appear red? It's because of a dye. Or my hoodie, you see, is it blue? It's blue. Nikiweka something hapa yenye ita bleach, itakuwa white. So absence of colors gives white. Now, this one, a color is called a dye. A color is called a dye. So HOCl plus a dye, and this dye is colored. It will give us hii oxygen itaingia kwa dye. Then it gives us a colorless matter. Colorless matter with no color plus HCl. You see? Plus HCl. Now, this chloric 1 acid has bleached the dye and now it's a colorless matter. So if you had your two litmus papers here, ulikuwa na blue na ulikuwa na red. Kumbuka, the solution is already acidic. Sawa. Now I'm answering the question I was asking you na mkakataa kunijibu. Now the solution is acidic. So the red will remain red. The blue will turn red. Don't stop there. The two of them now will become white. Why? Because it undergoes bleaching. Tumeelewana? Yes. There are those red litmus paper bleaches. Check on your spelling, Mulat Nasir. But it's good because you are the one giving us most of the answers. Is bleaching by reduction or oxidation? Kama inapeana oxygen kwa dye, that is bleaching by oxidation. And it is the most permanent. Sawa. Yes, so I think that question is well answered now. You have known it. Now, another question or another thing that I would like to emphasize. Hii swali nayo mtakutana kwa mtihani. Hii sitaki niwadanganye. Usipokutana nayo ukuje nikupe 5 bob. Na uniambie kama ni mimi niliseti hiyo mtihani. Ukuje uniambie. Sasa hii swali it's the most common one. Utakutana nayo mpaka form 4 mpaka KCSE. Especially when mnafanya next year. Hii mtakutana nayo. Sasa angalia hii. This is chlorine water. Sawa? This is chlorine water. Then we have sunlight. Either yandikwe sunlight ama yandikwe UV rays. UV rays na maana nini in full? Hiyo naye kama hujui ndakutwanga sasa. So the question is draw another setup at the end of the day. Draw another setup at the end of the day, then explain. Remember, if you leave this in a dark room, there will be no observation. So after one day, this is what will happen. After one day, this is what is going to happen. There is a space created there, and there is a gas Y. Name for me gas Y. Yes, we have a gas there. Name for me gas Y. Name for me gas Y. Yeah, UV means ultraviolet. What's gas Y? What is gas Y? Mkiniambia tutaendelea, msiponiambia sasa mtaniambia mnataka aje. Ndio tuingie kitu inaitwa noble gases. Kina Beva da watu kujibu na kina Njeri. Mnatakaje kwani? So let me check if the other people have answered me. Oxygen gas, yes, kuna watu wamesema oxygen gas. Yeah, gas Y is oxygen gas. Gas Y is oxygen gas. Good. Now, let's look at, unless kama uko na swali, I want us to look at the noble gases very fast. Our time is moving on, and I have only 10 minutes. I would like to look at the noble gases. Noble gases hata ina maneno mingi. Trust me, within the 10 minutes, tutakuwa tumemalizana nayo. Noble gases, group 8. These gases are referred to as the most unreactive because they are stable. They do not gain or lose electrons. And remember, for a substance to gain and lose electrons, it must I mean, for a substance to react, it must be losing or gaining electrons. Now, these ones, they do not gain or lose electrons. Now, iko na electron arrangement of 2, 8, and 2, 8, 8. They are known as the noble gases. Group what? Group 8. Yes. These ones include helium. This is now helium. These ones are the ones used in bulbs. Helium, neon. Then we have argon and now beyond here huku chini tuko na zingine zinaitwa xenon and krypton. But for you guys, stick to those three for now. These are the other members. Yes, they are complete. This one cannot gain. It cannot lose. It cannot gain. It cannot lose. All these because they are complete. Iko na kitu inaitwa duplet rule. Iko na octet rule, meaning they are complete having 8 in the outermost energy level. This one is complete having 2. Yes. Concerning these gases, okay, I will not give you what do we call? I will not give you the chemical properties because they do not react. But kitu moja nataka nikwambie, the other gases are molecules. Unajua ukiandika hydrogen unaandikanga hivi. Ukiandika nitrogen unaandikanga hivi. Oxygen inakaanga hivi. Chlorine inakaanga hivi. Fluorine inakaanga hivi. These ones ukiandikanga helium unaandikanga helium hivi. Kama ni neon hivyo. Kama ni argon ni AR. Aina maneno mingi ati this one they exist as monoatomic gases. Monoatomic gases. Right together. Alafu the other thing is they're colorless. All these they're colorless. Sawa, they're colorless. As you move down the group, there is an increase in the size of the atom. Why? Because of increase in the number of occupied energy levels. Sawa. What else? Xenon. Under specific conditions like high temperatures and presence of a catalyst, it can participate in some reaction. It can participate in some reaction. Did I tell them what about the explanation of the diagram? Oh, I did not explain the diagram. Yeah, oxygen. I will explain. You need to explain. Ibrahim anauliza swali lingine yenye nilikuwa nimejibu. Nimesema hivi, I'm alternating. Yeah, so you will find me. The other one is the other question I want to talk about, or the other thing I want to talk about is xenon can participate in some reaction, especially during high temperatures or presence of a catalyst. Are we together? Yes. Why are they used in bulbs? Because they provide inert atmosphere. Sawa. So unless kama kuna mtu akona swali stani kama hizi maneno za helium na nini kuna maneno mingi, ainanga maneno mingi, inakuanga tu hivyo. Lakini sasa mahali lazima ujipange ni hapo kwa uses. I want to give 7 uses of noble gases. Are you ready for them? Are you ready for it? Good. Let me say this. let me present to you. I hope you guys are following. Use number 1. Use number 1. I'm placing it there. It says it talks about argon is used in light bulbs to provide an inert environment to prevent oxidation. Mickey, you can project it. They use number 2. I hope you can see it on the screen. Use number 2. I'm saying argon is used as an insulator in arc welding. You can see it on the screen. Use number 3. Neon. Neon is used in street and advertisement lights. I'm getting to use number 4 now. I hope you are seeing these things on the screen. No, not on screen. I hope you are seeing them on the screen. I'm getting to use number 4. Number 4 says, helium mixed with oxygen is used in deep sea diving and mountaineering. The mixture is also used in hospitals for patients with breathing difficulties. Yes, when it is mixed with what? Oxygen. I'm getting to use number 5. We are going up to number 7. Use number 7. Helium can be used instead of hydrogen in balloons for meteorological research. Last, not lastly, second last. Yes. Mwenye ameuliza ni hivyo fenye nimesema. Lastly ndio hiyo. It says that liquid helium is used to keep certain metal alloys at temperatures low enough for them to become superconductors. Good. Unless kama uko na swali, I want to talk about what we are going to discuss tomorrow. Properties and trends across period 3. That's what we are going to discuss tomorrow. Whatever hiyo kenye nimeweka hapo kwa chat, nimesema properties and trends across the period, ama period 3 actually. Specifically, that is what we are going to see tomorrow from 3 p.m. to 4 p.m. So keep following our channels. We have 4 of them. We have Ambassador Speaks YouTube. If you have not subscribed to it, please go there, subscribe, share with others. We have over 200 chemistry lessons there, and physics lessons, and academic talks. Yes. Also go to Mixlet Media, follow it. Number 3, go to Shifting Grades online school, you follow it. Number 4, go to the Mathematics Guru. That's where you will meet some other lessons, your maths, and many other things there. So every day here we are live on Ambassador Speaks every day from 3 p.m. to 4. Shifting grades, we are alternating. It was not there yesterday, it is there today. Tomorrow it will be Mathematics Guru. Yeah, so otherwise I wish you all the best as you are learning, as you want to become a great person, a great scientist. We are here to help you reach there. So if there is no one with a question, I want to see if there is anyone with a question. I am giving out 1 minute. If you have any question, please type there very fast. Nikujibu sai. before we end and before we get out. First of all, where are you watching me from? By the way, I want us to appreciate our chemistry in the chat box. Niambie teacher and from which school. Kuna wengine hawataki kumention their chemistry teacher because teacher alimchapa kofi siku fulani, alishinda kuandika chemical formula ya sodium sulfate. Mwalimu akamwambia hii naye lazima utajua, kamweka slap. So who is your chemistry teacher? Nangojea chemistry teachers were appreciated by being mentioned their names. And the school, by the way, and together with the school, tuambie, which school are you coming from? Kesho tutaangalia the trends across Britain. Then the other day, on Saturday or on Monday, we shall be looking at what we call structure and bonding. Somebody is saying I have a question. I have said I gave out 1 minute for questions. Now again you're asking me I have a question. No, you should have given your question there. Mr. Mudami, pale Machako School. Hey, Mr. Mudami, feel appreciated. Yes. Utamwambia uli mention Madam Juma Star High School. Madam Juma pale Star High School. Sawa. Nasir, watching from Makweni, I'm a chemistry teacher. Thank you, Teacher Sam. Thank you for following your fellow chemistry teacher. Yes. In the next 1 minute, we shall be out. So, in the next 1 minute, we shall be out. Mrs. Chuma. Oh, amesema Mrs. Chuma. Wow, I'm so grateful for following us. Mr. Katumta. Bwana, I hope si Katumta namujua because afunzangi chemistry. Marley, you want to lie. Mr. Francis, pale Anista High School. Marley inspired by ungesema hivyo sasa, inspired by Katumta. Good. Now I'm getting you. Sawa. So Mr. M. Amin Nep Girls. Mr. M. Amin Nep Girls. Imfikie Mr. Amin. Kuna wengine wataki kumention walimu wao. Marley, huyo wa shifting grade. Tumekuelewa kitambo sana Marley. Tumekupata kabisa. So thank you for following us, and now